Okay, Cougars, it's that time again. Test time is coming up, so get out your Unit 2 study guides and let's work through some sample problems together. Shall we? Take a look at numbers 2 and 6, converting fractions to decimals. Anytime we convert a fraction to a decimal, we are simply doing a division problem. Every fraction is a division problem. You just take the numerator and divide by the denominator. Our numerator is 5, our denominator is 6, so it's 5 divided by 6. How many times will 6 go into 5? Well, 6 won't go into 5, but if we treat the 5 like a 50 and put the decimal point here, 6 will go into 50 approximately 8 times. 8 times 6 is 48. We subtract, we get a remainder of 2, bring down a 0. 6 will go into 20 approximately 3 times. 3 times 6 is 18. We subtract, we get a 2, and I think you see the pattern already. 5/6 is really the same thing as 83 hundredths with a repeating 3 hundredths. Let's take a look at number 6. Now number 6, we have a mixed number. Don't lock up, don't get worried about the mixed number. We know that this is really 2 and a third, which is the same thing as 2 plus 1/3. So let's figure out what 1/3 is, and then we will add it to 2. So again, 1/3 is a division problem. 1 divided by 3. 3 will not go into 1, but it will go into 10 3 times. 3 times 3 is 9. We subtract, we get 1 as a remainder, and I think you already see the pattern. So we know that 1/3 is 3/10 repeating decimal, but we need to add the 2 onto it. So we get 2 and 3/10 repeating decimal. Oops. The next part of our review deals with converting decimals to fractions. And I really don't think it gets any easier than this. All you have to do is be able to read the decimal properly and then reduce it to simplest terms, or I should say simplify it. So what do I have here? I do not have 0.65. That is slang. We don't use slang in math class. It's 65 hundredths. 65 hundredths is exactly that, 65 out of 100. When I look at the numerator and the denominator, I see that I can factor a 5 out of both. Okay, 5 will go into 65 13 times, and 5 will go into 100 20 times. So I have 13 twentieths in simplest form. Over here, 18, I have 2 and 77 hundredths. Okay, so I have 2 and 77 hundredths. And the factors of 77 are 7 and 11, and the factors of 10 are 2, 5, and 10. They do not have anything in common, so that was really easy. 2 and 77 hundredths. That could not be reduced or simplified. Well, here it comes. This is hands down the most difficult part of Unit 2, but we can handle it. What we're doing is we're converting repeating decimals to fractions, and the trick with that is we've got this decimal that just keeps on going and going, okay? 8/10 repeating decimal is 8/10 plus 8 hundredths plus 8 thousandths plus 8 10,000ths, and it just keeps on going. And the idea of trying to express that as a fraction is a real headache, so we need the help of an equation. And the first step for this equation is we simply need to assign a value to this so we can kind of manipulate it, and we're going to use a variable. So we're going to say x is equal to 8/10 as a repeating decimal. 0.8888 just keeps on going. Then my next step is I need to change this repeating decimal to a mixed number. And the repeating digits, that has to become a whole number. So I need to move the decimal point over one place, which means I need to take and multiply it by 10. And what I do to one side of the equation, I'm going to do the other. So now I have 8.8888 repeating decimal. Okay, you might say, well, that's nice. Now, here comes the slip part. Now we're going to get rid of this annoying repeating digit. And how we're going to do that is we're going to subtract it. Okay, I'm going to take it away from both sides. If I get rid of this 8.888, which I've assigned the value of x, I'm going to take it away from this side and take it away from this side, and look what happens. Now I have something a little more manageable. 10x minus x will leave me with 9x. And then 8.888 repeating decimal minus the repeating decimal part will leave me with 8. Okay, This is a lot more friendly and a lot more easier to wrap my hands around, or at least my mind around. Now, to get the final answer, I need to get the variable isolated all by itself, and once I know what x is, that's my answer. So I want to isolate x, so I divide both sides by 9, and x is equal to 8/9. That is my answer. So 0.8 repeating decimal is the same thing as 8/9. There's my answer. Now this next one is a little more tricky. Here, and what makes it a little more tricky is I have a repeating digit that comes after a non-repeating digit. Okay, what I have is I have 98 hundredths with 8 hundredths. It keeps on repeating. So I start out the same way. I need to assign this a value. Let's say x is equal to 0.98888, and then I'm going to change this into a mixed number, and I need to make the repeating part of the whole number. So I'm going to move this over, this decimal point, 2 places to the right. So I need to multiply it not by 10 this time, but by 100. And when I do to one side, I do to the other, and what this is going to give me is that, okay, 98 with 8/10 repeating decimal, just keeps on going. Now, I want to get rid of this repeating decimal part, okay, and if I were to subtract x from it, let me just show you here, I'll do it in green real quick. Okay, if I were just to take x away, you see, that just wouldn't work. That doesn't help me. It would actually make it a lot more confusing. So what I got to do is I want to get rid of the digit that keeps on repeating, which is 0.8. So instead of just bringing x, I'm going to bring 10x. Oops, let's change that color. That color doesn't show up that well. Blue. Okay, so I'm going to multiply it by 10, and 10x, look at this, 10x is going to be 9.8 repeating decimal. See, I'm just moving the decimal point over 1 rather than 10. And that's what I want, because now I'm going to get rid of the repeating digit 8. Okay, and I subtract it from both sides, and now this won't give me 99 or 9, it'll give me 90x is equal to, okay, the repeating decimal part cancels out, thank goodness. Then I got to do some regrouping here, make that an 18. 18 minus 9 is 9, and I'm going to get 89. Okay, sorry about that, that's 89. And then I want to isolate x, so I have to do the inverse operation. 90 times x, the inverse operation is divide by 90. When I do to one side, I have to do to the other, and I'm going to get x is equal to 89 90ths. And I do not believe that we can reduce this at all, so my final answer is 0.988 repeating decimal is going to be the same thing as 89 90ths. Let's go down to the word problems, numbers 33 and 34. Number 33 says, Joseph mowed 63% of the lawn, while Darius mowed 27 hundredths of the lawn. How much of the lawn is left to mow? Well, there's only one lawn that's being mowed, and they're both doing a fraction of it. Joseph's doing 63% of it, and Darius is doing 27 hundredths of it. Really, all we need to do first is just get a common type of number, and I'm going to work with decimals. I know that 63% means 63 out of 100, and 63 hundredths is also a decimal. And then Darius, he did 27 hundredths of the lawn. Let's add these together, 7, that's 10, carry the 1, 3, so that's 9. Bring my decimal point down. So altogether, both of them did 90% or 90 hundredths of the lawn. Well, I know that the whole lawn is one whole, and if I subtract 90 hundredths, I'm going to be left with 10 hundredths of the lawn not mowed. Okay, so 10 hundredths or 1/10 of the lawn is not mode, because this is the whole lawn. This is the part of the lawn that is mode, and then 10/100ths is the part that's not mode. Well, there's an old saying that a picture's worth 1,000 words, and I don't have time to speak nor write 1,000 words, so let's draw some pictures here. We're going to deal with creating a little diagram here that helps represent the real numbers. Real numbers are numbers that we use in the real world. There is such a thing as imaginary numbers, but you can deal with that later in pre-calculus. Right now we're going to deal with real numbers, and it all starts off with our natural numbers. They'd be 1, 2, 3, and 10 and so forth. Those are our natural numbers, also known sometimes as counting numbers. Those are our natural numbers, and we'll put them right in that little circle there. And then if we take all of our natural numbers and add 0 to it, that would be, it's called our whole numbers. So there we have our set of natural numbers, and whole numbers would include all of the natural numbers, all counting numbers, plus 0. Then we can go, every whole number has an opposite, okay? Those are called integers. So when we take, 9 and -9 and 3 and -3, they would fall into the classification of integers. So integers would be all natural numbers plus 0, which would include whole numbers, and then all of those whole numbers also have opposites, also known as negatives. So integers, so all positive and negative whole numbers. And then we have another category outside of this, and they would be, they're rational numbers, okay? And rational numbers are numbers like 3.5, okay? It's a fraction. It's the numbers in between our integers. Okay, integers go on forever, both positively and negatively.
Mr. Cruz, please call in section 100. Mr. Cruz.
Sorry about that. And then we also have those fractions in between, like half, and they can be represented as decimals or fractions, and they can even be, numbers like 123 thousandths. Okay, has a definitive end. It can even include repeating decimals. Like I know 1/3 is 0.3 repeating decimal, and I might say, but that just keeps on going. It does, but it's rational now that I've figured it out. I know what the next digit's going to be. It's always going to be. Okay, the last type of number that falls in the category of real numbers is irrational numbers. Now, irrational numbers are numbers like pi. They're basically fractional numbers, decimal numbers that they just keep on going. There's no end, and it's not like a repeating decimal where we figured it out and we see a pattern. There is no pattern. If someone says they know what pi is, we don't. It's our best guess, I should say, a common approximation is 3.14, but that decimal, those digits just keep on going, and there's no known repeating pattern. It's just random. Another example would also be a number like the square root of 2. Okay, those are rational numbers. They don't have a definitive end. I hope that was helpful, and we will do the second part of the study guide tomorrow. As always, boys and girls, I hope that was helpful, and if you have any questions or any unresolved problems, bring them to class tomorrow and we'll work them out. Have a good evening. Bye-bye.